Hello, my name is Christopher Clark, and I'm going to be presenting Molmo and PixMo, building state-of-the-art open vision language models. This is from AI2 and many collaborators. And now I want to start by giving a quick demo of what Molmo can do. So the great thing about Molmo is that it's open, so the model data and code are all released. Now, typically open VLMs have been outperformed by closed ones. For example, if you look at these ELO scores from Chatbot Arena, the only open data model here, Lava 1 Vision, is being significantly outperformed by all these closed data models. And of course, the reason for this is just that the open data sets we have for VLM training are not nearly as good as the closed ones used by these closed data models. So PixMo and Molmo are our solution to this. PixMo is a set of high-quality VLM datasets for training. Notably, we built this without using any proprietary VLMs, so the entire pipeline is transparent. And then Molmo is our model trained on top of these datasets. It includes some new modeling tricks, and it also has some novel pointing capabilities that I demoed earlier. And then to cut to the chase, Molmo is a huge advance on the previous best open data model, and it's sort of in the middle of the pack of these closed data models, so a big step up of what you can do with open data in vision language modeling. And then I'll go over some academic benchmarks as well. So just to summarize very quickly, Molmo is very good on VQA benchmarks. It's very strong on OCR benchmarks, but a bit behind the best open weight model. It's really good at counting because it can count by pointing to things one at a time. And then it's a bit behind on reasoning, we think because we didn't include much reasoning NLP data in our training mixture. So now I'll give a few details of how we built these components. So PixMo is a huge data annotation effort. It has millions of annotations, both from humans and through synthetic data generation. There's a lot of interesting ideas in PixMo. I'm just going to show one here, and I'll leave the rest to the paper. So an important data set here is PixMo Caps, which has long, detailed captions for images with 400 to 500 words. And to get this data, we had users talk in a microphone about the image for 90 seconds. And then we transcribed that audio and rewrote it the language model to get a caption. And this ends up being much, much easier for people than trying to type things out by hand. There's a lot of other ideas in the paper, but I'll leave it at here for this talk. And then for the Molmo model, it's a pretty typical VLM. So it'll take an image, break it into crops, and encode those crops to get visual tokens, which are combined with text tokens into a long sequence, which can be passed into a language model to generate output. There's a few new modeling tricks here. So our crops actually overlap slightly, like around the borders, which lets you get patches with more context when encoding them. We had a useful trick of training on multiple annotations for one image to make training more efficient. And then we had the simplified two-stage pipeline where the learning rates and warm-ups were different for the different components. So you can look at the paper for details on all these pieces. So then we pre-trained the model. We pre-trained just on dense captions. We do find it useful to use both the raw transcript and the rewritten language model caption and to do length conditioning. So both of these improve downstream performance. And then we fine-tune on a mix of data, both PixMo data and a set of academic data sets. And that's how we got to Molmo. So Molmo is open, so you can download it. You can also try it yourself in the playground. Thank you.